Hello. In this video, we're going to use tree diagrams to calculate probabilities, as shown in the syllabus. We're going to use both of these formulas shown on page 9 of the formula booklet. And in particular, the second one, where the probability of an event A plus its complement add up to 1. Tree diagrams are useful to show you the possible outcomes, especially when the second event depends on the first, as you'll see later in the video. In this example, where two coins are tossed, you can see the outcomes of the first coin, shown here, heads and tails, and the outcomes of the second coin, heads and tails, and repeated below. So you can see that overall, the tree diagram shows that there are 4 possible outcomes. In this example, where a spinner is spun 3 times, you see that the tree diagram shows us that there are 8 possible outcomes. The first spin, the outcomes are either blue or white, and then that's repeated for the second spin and repeated again for the third spin. In this question, we're asked to draw a tree diagram to illustrate the situation. So C represents the event that the car starts, and M the event that the motorbike starts. So either the car starts or it doesn't start. So it doesn't start being the complement of starting. So C dash is the complement of C, and M dash or M prime is the complement of M. Remember our formula that the probability of an event plus its complement will always add up to 1. The probability of the car starting is 80%, so we write this as a decimal, 0.8. So the probability of it not starting will be 20%. 80% plus 20% making 100%. And 20% we write as 0.2. For the motorbike, the probability of it starting is 60%, so the probability of it not starting is 40%, 0.6 and 0.4. And we put these twice, following on from the 2 outcomes of the car. Now the tree diagram is complete, we'll list the outcomes. As you can see, there are 4 outcomes. To obtain the probability of each outcome, we multiply along each branch. So for the first outcome, we multiply 0.8 by 0.6, and that will give us the outcome that both vehicles start. You can see the other results shown here. Second outcome, 0.8 multiplied by 0.4. Third outcome, 0.2 multiplied by 0.6. And the final outcome, 0.2 multiplied by 0.4. Finally, add up all your probabilities and check that they add up to 1. Now the tree diagram is complete, we can use it to answer the following 2 questions. As stated before, the probability that both vehicles start the top branch with 0.8 times 0.6, and that's equal to 0.48. The probability that Carl can only use his car means that the car starts and the motorbike doesn't start. And that's the second branch. So that's 0.8 times 0.4. And that's equal to 0.32. In this question, we're asked to calculate the probability that the child chooses at least one red toy. For the first choice, there are 10 toys to choose from, and 4 of them are red. So the probability of choosing red would be 4/10. And there are 6 green toys, so the probability of choosing green first would be 6/10. Again, remember, whenever the trees branch, the probabilities have to add up to one whole, as shown there. For the second choice, having already picked a toy, the child cannot pick the same toy a second time, so now there are only 9 toys left to pick from. If the child had first picked a red, then that would leave 3 more reds to pick from, so the probability of picking a red the second time would be 3/9. And that would still leave 6 greens to pick from, so the probability of picking a green would be 6/9. If the child had picked a green first, then that would still leave the 4 reds to pick, so the probability of picking a red would equal 4/9. And if the child had picked a green, then of course that's 1 less green for the second choice, so the probability of picking a green again would be equal to 5/9. Again, if we list all the different outcomes now, you can see the 4 outcomes there. And again, calculate the probabilities of each outcome by multiplying along the branches. So the probability of picking 2 red toys is 4/9 multiplied by, 4/10 multiplied by 3/9 equal to 12/90. And so on. Again, when you've calculated your probabilities, it's good to check that they all add up to 1. So here, if we just add the numerators, we've got 12, 24, so that's 36, another 12, so that's 60, and 3 more making 90. 90/90ths is equal to 1. Now the question asks us to calculate the probability that the child chooses at least one red toy. So next, let's identify which of those outcomes satisfy that requirement. And the first 3 outcomes do. So to calculate the probability of choosing at least one red toy, we need to add those 3 probabilities together. The probability of picking 2 reds, and a red followed by a green, and a green followed by a red. And if we add those together, you can see the answer is 2/3. Another way to solve this problem is to use the law of complementary events. In other words, find the probability which is the complement of at least one red toy, that being the probability of no red toys, and then subtracting that from 1. The probability of picking or choosing no red toys means that the child picks 2 green toys. And that was the bottom branch of the tree diagram, and that was equal to 30/90ths, which is equal to 1/3. So the probability of picking at least one red toy is 1 minus the probability of picking no red toys, which is 1 minus 1/3, and again is equal to 2/3. In this question, we're asked to find the probability that Lucas takes a can of soup, which is chicken. So if we again start by drawing a tree diagram. The first section of the tree diagram is to do with the choice of shelf. We're told that Lucas is twice as likely to take a can from the bottom shelf as he is from the top shelf. So thinking about that ratio of 2:1, twice as likely, 2:1, that means that there's a 2/3 chance of taking it from the bottom shelf and a 1/3 chance of taking it from the top shelf. 2/3 is double 1/3, in other words. Now the top shelf has 5 cans of soup, 3 of which are pumpkin. So the probability is 3/5. 2 cans of chicken soup, so the probability is 2/5. And on the bottom shelf, 4 cans of pumpkin, so that's 4/5. 1 can of chicken, so that's 1/5. Now we're asked to identify or find the probability that he picks a can of chicken soup. So let's identify which two branches of the tree diagram that is. And I've labelled them 1 and 2. So to find the probability that the can picked is chicken, we need to add those two probabilities together. And again, remembering to multiply along the branches, so that's 1/3 times 2/5, 2/3 times 1/5, and that gives 4/15. In this last part of the question, we're told that given that Lucas has a can of chicken soup in his hand, what's the probability that it came from the top shelf? So effectively, this reduces the sample space down from the 4 outcomes to just those 2 outcomes, as shown. So to calculate the probability that it was taken from the top shelf, it's just the probability of the first root out of both roots. So the top of the calculation has the first root, okay, 1/3 times 2/5, or in other words 2/15, out of 4/15, so the answer is equal to 1/2.